Hello everyone and welcome to our 8th webinar of the ASNT UAE section. A bit of self-introduction, and for those who never joined us before, I'm Abdulrahman Taqatak, Education Director for the ASNT UAE section. Tonight our presentation is arranged by GNDT Dubai, thanks to Mr. Gareth Venture for his support. Gareth is the General Manager of GNDT Dubai. As usual, we would like to invite all of you to join our LinkedIn page to know more about the section activities. We will share the link for the page in the chat box during the presentation. I would like to remind you to fill the feedback form. We will share the form during the QA session as usual in the comment section. We issue attendance certificate to those only who filled the form. So if you have any difficulties in accessing the form or any issues, please let us know during the presentation, or you can write to us after the presentation so we can share the link with you. If you have any questions, please type it in during the presentation in the comment section. The presenter will answer all the questions after completing the presentation. Tonight we have Mr. Jan Albert and Mr. Evan Leroux presenting from Gammatec, South Africa. Jan Albert is a senior sales engineer from Gammatec. He will be presenting the theoretical part. And Evan Leroux is the innovation manager at Gammatec Group, and he will be presenting the live demonstration. I will leave you now with Jan, and I trust you will get an informative and interesting session. Over to you, Jan.
Abdul, thank you so much. We really appreciate the opportunity, and thank you for the introduction. I'm going to ask you to just stop sharing your screen, and then I can start with the presentation side. Guys, just a couple of rules. We are quite a few people here tonight. We're going to keep everyone on mute, as Abdul has notified. As well, please type any questions you have during the presentation in the chat box. We will try and answer them live, and then Abdul and then will also highlight some questions at the end of the presentation for us, and we will answer them live to the members here today. All right. Okay. So welcome everyone again, and thank you for joining. We are very honored today to meet with all of you here from the ASNT UAE chapter, and we appreciate your attendance and time, and Abdul as well. To you again, thank you for the opportunity. We appreciate the opportunity to showcase you the advancements that have been made and that are available in terms of radiation safety, utilizing close proximity radiation systems. Today, just a quick overview. We will start with a presentation on close proximity radiography. We are going to highlight safety and cost savings, increased radiation safety, training in ALARA culture, how the GamCPR system specifically achieves close proximity radiography by doing a live setup. And then when we're done with that, we're going to take some questions. For ease of reference today, when we refer to CPR, we are referring to close proximity radiography as a genre. And when we refer to the GamCPR, we are referring to the Gammatec system specifically. Right, then, as said, contents of today's presentation will be close proximity radiography explained, where to use CPR and why, what are the most common CPR shot applications, and then why to use the GamCPR system. Okay, what is close proximity radiography, or CPR? CPR is the conducting of radiography in close proximity to authorized radiation workers, members of the public, or radiation-sensitive monitoring devices, in such a way as to ensure continuous operations. CPR is achieved by utilizing a system of X-ray or gamma ray emitting devices, incorporating specific collimation with rigid and or flexible shielding to reduce the primary beam and scattered radiation to safe levels at the desired barrier distance. You will see on the slide a visual comparison between conventional radiography on the left and proximity radiography on the right. The GamCPR system was specifically developed to ensure higher productivity rates, not only for the NDT and radiography teams, but to ensure cost savings, increased productivity, and increased radiation safety throughout the entire worksite. So where to use CPR and why? We know that wherever radiography is being conducted, there are large exclusions or safety zones where other workers are not allowed to enter. With CPR, we are able to keep workers at their designated posts. Restrictions on movement within a site causes lost productivity, stops production, and affects planning in all departments, not only where radiography is being conducted. You can ask yourself, how has conventional radiography impacted your work programs in the past? What if you could reduce the safe working distance and the production downtime through lower radiation levels in the work area? By utilizing CPR, you can avoid general workers not being able to get to their designated posts or to conduct their daily tasks because of access issues while radiography is being conducted. There's no closed roads where piping runs nearby, no instrumentation engineers unable to do their daily checks, and no other NDT work around the same area is influenced, accelerating shutdowns and improving on productivity in general. We're going to look at where you can't use close proximity radiography. So almost anywhere where radiography is required. The GamCPR provides massive cost and productivity benefits when utilized during shutdowns, during maintenance and turnaround on plants, in areas utilizing radiation-based technologies for process measurement, new build projects, and to accelerate construction programs. It's also very well adapted for onshore as well as offshore work. Make use of close proximity radiography, you will have no shifts lost due to radiography. You will change your downtime into productive time. You will accelerate construction programs. You can maximize the plant utilization, and you'll have a quicker startup and return of plant to the asset owner. So let's delve in and look a bit at that. Why should asset owners in production facilities consider using close proximity radiography? We're going to look at 3 simple reasons. Firstly, the massive cost savings, the radiation safety. You can achieve true ALARA principle for general workers and the radiography teams. And then, of course, you're going to be looking at improved image quality, utilizing that selenium-75 source that provides a high-quality radiograph and works instantly with digital radiography solutions as well. So first up, we'll look at the massive cost savings by eliminating non-productive costs. The GamCPR reduces the safe working distance, eliminates those conventional radiography windows, and eliminates the need to evacuate an area and maximizes the utilization of plant. All right. We're going to have no shifts lost due to radiography. You're going to change that downtime into productive time. You will accelerate construction programs, and you have maximized your plant utilization and have a quicker startup and return to the owner of the plant. Okay. All right, point number 2 for close proximity radiography is radiation safety. Now, the close proximity radiography will enable you to reduce radiation levels on site for everyone. You are going to reduce dose rates to radiographers, ensuring the safety of your teams. You're going to reduce and eliminate dose rates to the members of the public because you are in control of the radiation readings. One second, sorry. You're going to reduce the chance of radiation incidents because the GamCPR puts the radiography team in control of the barriers they need to achieve and to know exactly what to expect when going on site. There will be no more chance of scattered radiation or of someone unknowingly entering a large radiation barrier zone. This is a key advantage undertaking close proximity radiography because the radiography team will be empowered to be in control of radiation levels. Utilizing the GamCPR system, we get barriers down to only a few meters versus conventional radiography that could have exclusion zones of up to 100 meters and sometimes more. You also make the entire site a safer place. You have far less area to keep safe, and you can keep the public out while radiography is being conducted. So using that selenium-75 isotope and using specifically designed collimation, we can then significantly reduce the radiation levels for everyone. The third point that we talked about is on the selenium-5 and selenium-75 isotope and improving the image quality thereof. So by using a radioactive source that will provide a high-quality radiograph, the use of selenium-75 for industrial radiography has gained wide-ranging acceptance. The advantages of selenium-75 over iridium-192 are in short, improved contrast, better sensitivity, improved resolution, a much lower energy range, which is easier to shield, and of course, a longer half-life of 120 days in total. So that more or less, these covers the massive advantages, and what we've discussed now, it covers the massive advantages of running a close proximity radiography setup on site. So if we move on, we can now look at the system itself and see what it is made up of. And then, of course, on how we achieve and ensure safe close proximity radiography. We want to quickly touch on that before we move on to the actual setups. So how do we achieve and ensure safe close proximity radiography setups? Firstly is the knowledge of how radiation works and using purpose-built equipment. And we're going to show you that in the next couple of slides, and we'll show you that live as well. We use time, distance, and shielding, the basic laws of radiation safety. We improve on the shielding to reduce the distance and therefore the time spent to higher levels of radiation. We utilize the lower energy of selenium-75, the uniquely designed selenium-75 gamma ray protector, purpose-built collimation, flexible and purposely designed shielding. We create a safety culture of ALARA, and then training. Gammatec gives a comprehensive training to each GamCPR customer to ensure a good safety culture at the end of the day, and safety objectives aligned with the ALARA principle. In that training, when utilizing the system, we teach people on how to achieve close proximity radiography, how to utilize and deal with primary beam shielding, and how to deal with scattered radiation. All calculations and methods pertaining to close proximity radiation, and we also teach them the best practices related to the equipment. So we're going to look at and jump into and ensure that the system is made, for purposely on site and that it can be used in a wide array of applications. So on screen, you will see the most common close proximity radiography shot applications. The system is flexible enough that it can be adapted to any radiography work that needs to be undertaken. Close proximity will lower down the radiation barriers on a site. The GamCPR system uses uniquely developed systems of clamps, stands, shielding mats, and other accessories to allow for radiography on various pipe configurations, including pipe to pipe, pipe to elbow, pipe to T, pipe to reducer, pipe to flange, and pipe to socket. These are the most common applications for it. In pipe to pipe configurations, you can see here that we do a contact shot using a collimator and a shielded guide tube for when access is not that great and there's not enough space. We can do a contact shot with the projector wrapped in our shielding material. We do a standoff shot forward ellipse with a cone up to 3 inches. We can do a standoff shot forward ellipse wrapped up to 4 inches. And then a standoff shot superimposed with a cone straight from the top up to 2 inches. Then for pipe to elbow configurations, we can do a contact shot with the projector wrapped close to the elbow. We can do a contact shot using a collimator and a shielded guide tube. And we can do a standoff shot, a backward ellipse or superimposed wrap up to a 4-inch pipe for the GamCPR system. We can also do pipe to T configurations. We can do the same contact shot, just with the projector wrapped. The contact shot using the collimator and the shielded guide tube, if there's no space for the projector. And we can do a standoff shot, backward ellipse or superimposed, wrapped up to 4 inches into that T configuration. We can also do pipe to reducer with a contact shot, projector wrap, a contact shot using the collimator and the shielded guide tube, and then a standoff shot, backward ellipse or superimposed on that pipe to reducer configuration, no problems. There's also the pipe to flange. When doing a pipe to flange configuration, we can do the contact shot using the collimator and the shielded guide tube, or we can do a standoff shot backward into the ellipse or superimposed, wrapped up to 4 inches, when you are close to that flange. Also pipe to socket. That's a standoff shot superimposed, wrapped up to 4 inches. Right, so that covers all the existing setups possible with a standard GamCPR kit and what you would get from Gammatec when ordering that. We can, of course, custom make and test specific applications for a customer if the requirement is there, and we will design what is needed to achieve close proximity radiography. You can get in touch with us if you have any unique applications not listed here. Okay, what is next? Something the next design phase for the GamCPR systems is our T-weld configuration for tank applications in not only existing builds, but for new tank builds. We'll be looking to achieve close proximity radiography in such a fashion that radiography can be conducted while tank construction and welding is underway in the same space. We use powerful magnets to attach the projector to one surface and lead shielding behind the film on the opposite surface. Custom apertures reduce the radiation beam to within a shielding footprint for the tank T-shots. We're also developing a profile shot configuration for corrosion and wall thickness application. So these are the items that we are slowly developing to enhance that close proximity radiography offering. Okay. We'll look at why you want to choose the GamCPR system specifically. First up is the Circa tungsten projector, which is a lightweight field loadable system weighing only 8 kilograms. Of course, it has no depleted uranium. So in countries where that is a problem, where shielding in terms of projectors is concerned, you can utilize the system. When the projector is empty and there's no isotope inside, it can also be shipped as general cargo. Secondly, we've got purpose-built collimators and apertures. So custom apertures reduce the radiation beam to within the shielding footprint. And we can custom make this according to any other requirements you might have, although you do get custom apertures inside your system to cover most ranges of what we've discussed in the setups previously. We have a specially designed clamp and stand for easy setup. It's an articulating arm that allows fast setup for profile shots or standoff shots like you've seen. There you've got the flexible and robust shielding mats. So there's a fast shielding setup times and a wide range of pipe configurations that are made easy with this flexible shielding material around user-friendly clamps and stands. And then, of course, we've got the unique safe working distance calculator. So with the GamCPR calculator, which we'll discuss just a little bit later on, you will see how we can calculate what we're going to find on site even before we go there. Quickly on the Circa 80 projector, which is custom built for the GamCPR system, capable of holding up to 100 curie selenium-75 source. It's got snap-on technology. The collimator eliminates the flash as the source transitions between the projector and the collimator, and it can be used for close proximity or conventional radiography. So giving you flexibility in those terms, where if you are not conducting CPR and you've got some other work, you use the same projector, use the same fittings that you get in your kit to do conventional radiography, if that is what is needed. We've touched on the shipping and the transport. It's lightweight and compact in terms of shielding, no depleted uranium inside this projector, making it very lightweight. And of course, it doesn't do any damage or adds any weight when you're doing radiography on site to the pipe work you have. The collimation and the shielding, you've got the purpose-built collimator and apertures. The purposely designed directional collimator features a 38-degree main side port with interchangeable apertures for further beam shaping and the reduction of the barrier distance. The custom apertures reduce the radiation beam to within the shielding footprint. And the port and the collimator can swivel through 360 degrees, setting you up to do that radiography in any direction that is needed. The standard directional collimator is used in conjunction with the shielded guide tube for when there is not space for the projector and the snap-on collimator. Now we've got the flexible, robust shielding mats and cones, which we will also show you very shortly. It ensures that they've got fast setup times and a wide range of pipe configurations that are made easy to shield. They are reinforced with Kevlar, and they work with user-friendly clamps to ensure quick setup times. We've got a purpose-built shielding cassette designed to hold 28 millimeters of lead, tungsten, or other shielding material to drastically reduce primary beam radiation levels. And then we've got the purposely designed shielding cone, which you'll see shortly, and to use in conjunction with that standoff shot and the Circa CP snap-on collimator. The shielded guide tube or any other thing which you can interchange to further collimate that beam and reduce any scattered radiation and contain it within there. You'll see on the bottom right, we've got the shielded cone there, which we'll show you shortly. A simple and easy to set up system, a couple of parts that snap into place, and a couple of terms, a very easy two-person setup that shouldn't add any time to your current radiography setups. It's got a quick connect clamp and a ratchet strap system for the contact shots. And then on standoff shots, we've got a quick connect clamp and stand system, a shielding cassette in the cone, and the support legs with the flexible shielding mat to ensure that the wrapping of the system at the end of the day to reduce that scattered radiation happens as fast as possible. Okay. Talk about the GamCPR calculator, which is displayed here. So this enables the user to calculate exactly what he will need to achieve the correct readings at the barrier. The calculator is a multifunctional tool and can be used to calculate one of a couple of things: the readings at the barrier with a specified shielding amount. You can calculate the barrier distance with a specified shielding and the microsiever that you need to achieve at the barrier. You can also calculate the curie strength of the source needed to achieve set barrier readings so that you know what you can do depending on site. And you can, of course, calculate the shielding required with a set barrier distance or readings at the barrier. The GamCPR calculator was developed with real-world setups and trials to calculate the reduction curve created by the different shielding materials used in the GamCPR system. So watch this space. GamCPR is only going to grow with further development and the system that we have. We imagine a productive work environment for all safe and 24/7 productivity. Thank you very much. That's it for the presentation part. I will stop sharing my screen. If there's any questions, please remember to drop them into the chat box. We are going to cut over to Mr. Ivan Leroux and Mr. Philip Borchardt, who's going to do the setup for you today. We are going to start off firstly with a simple contact shot using the snap-on collimator of the Circa 80 projector. Wrap that up, show you some radiation readings at very, very close distance so that you can see it. And from there, we will also do a standoff shot. Secondly, into a 2-inch pipe. And are we going to, what's the third one? We're going to do a reverse one as well. Just a wrap shot straight from the start. So other than that, just give us 2 seconds to change up cameras and views, and we'll hand you over to Mr. Ivan Leroux, who's going to do the actual setups of the system. Thank you.
Good evening, everyone. I'm Ivan Leroux, as Jan Albert has introduced me. As is mentioned, we will start off by doing a contact shot on a 6-inch pipe, which we will wrap with flexible shielding mats. As is mentioned in his presentation, these are Kevlar embedded, which makes them incredibly strong. We will start by wrapping 3 layers . So these take care of your primary beam radiation. Next is we will show you the snap-on technology of the collimator. So the collimator has got a concaved surface, which means there's no flash of radiation when the source transfers from the container into the area of exposure.
The kit comes with 3 or 4 different sized apertures, which you would select based on your footprint you require. And this drops into place and pulls into the ring. And once you tighten the lock nut, there's no way that this can actually be dislodged. And then you have the snap-on technology, which clips onto your container quick and easily. So what we'll do next is we will actually fit the container onto the pipe and prepare for the actual exposure. So we are using the Cylind 80 Circa. The center line of the collimator indicates your area of exposure. So you align that with your actual well. And you just flip over your ratchet strap. And then tension it to keep your projector in place. Next part is we insert a scatter cone over the collimator to reduce the scatter coming off the pipe. So at this point, we will expose with 3 layers of primary beam mat at the bottom and only the scatter cone over the collimator. So at roughly a meter, we are at 1.3 microsieverts per hour. 1.5 mats. Okay. Obviously, the primary beam radiation is slightly higher, but with an additional layer of Sulflex mat, we can easily reduce that to a much safer reading, which we will show you right now. So with the first reading, we were at roughly 90 microsieverts per hour. With an additional layer, we will see what the reading is now. So at roughly 800 millimeters from the source, we are averaging 23 microsieverts per hour.
allemaal continu in touwen camera's. Dus van de 200 graden.
Dat is geen primary beam, dat is klaar.
Okay. So that takes care of the primary, or the contact shot setup. What we'll do now is we'll break off this setup and do a standoff shot. So what we've got here is a 2-inch pipe. We will slide over our clamping system, make the chain. So now we've got our clamping system in place. Next is we will slide over our primary beam cassette. In this case, it's loaded with 28 millimeters of lead, 7 sheets 4 millimeter thick each. So instead of flexible mats, we will use, for this specific shot, our shielding cone, which is basically 2 stainless steel shells with 5 millimeter lead encased between them. So we'll slide over our projector. And at this point, we will use our laser alignment tool to ensure that you are completely aligned with your weld. So basically this just attaches onto your collimator, that engages with your aperture and centralizes with your primary beam radiation, and then you can align your collimator specifically to your weld. So in this case, we are slightly off, which we can easily adjust by just loosening the projector pipe clamp and aligning to your actual weld. And then you lock it in place. And then remove your laser alignment tool. If you work on a coated pipe and there's a concern that the pipe might get damaged by the chain, we do supply canvas sleeves which you can just slide over your chain and make sure that's between your chain and your pipe surface, which will then eliminate the risk of damaging a coating or coated surface. Drop the cone into place and lower the projector with its collimator onto the cone. And lock it in place. So this cone was specifically designed for up to a 2-inch standoff shot. When you do go smaller, for instance, a 1-inch shot, there will be a slight gap around the cone orifice, which in that case you can easily cover up with a lead shot bag in the back or front. Okay, and at this point we are ready to expose. So we have exposed, and at 1 meters we are at roughly 2.5 microsieverts per hour, which is well below the 7.5 microsievert requirement at 3 meters. We are at 1 meter at 2.5. If we look at the primary beam, in this case, at roughly 1.2 meters, we are at 0.45 microsieverts per hour. So as you can see there, we are roughly at 0.4 microsieverts per hour at a distance of about 1.2 meters. So what we'll do next is we will wrap a setup where you do not use your cone, but rather use the shielding blankets or mats. So for that, we supply arms to insert into your stand so that you can create a structure around your collimator and film so that your mats do not infringe on your actual shot. Okay, so now we are ready to expose. So as you can see on the camera, at the primary beam level, we are still well below 0.4 microsieverts at the distance of 1.2 meters. And at roughly a meter, we are below 1 microsieverts per hour on the sides of the shot. Currently, the source is at 24 curies. For areas that you do not have access to assemble the entire system, we do supply a tungsten shielded guide tube, which is quite flexible to get into confined spaces where you might have a pipe rack or something where you can't assemble the entire system, but you'd still be able to wrap around the pipe that might be next to the one that you're actually doing on a contact shot with. So this connects onto your projector similar to what the collimator does, and you would then use it similar to the normal contact shot where you would wrap this with your shielding materials. We supply a Velcro strap which can be used to keep it in place before wrapping. And that in short is the 3 setups we wanted to show you this evening. If there's any questions, you are welcome to fire away.
Okay, hi everyone, I'm back. You would have seen me obviously standing here to the side of the system. I'm not an integral part of the system. Unfortunately, I do not come with it. We were just holding down the pipe because we aren't bolted to the floor, and the system does have some weight. They're going to break down the system now so we can expose some of the parts and quickly talk about them and some of the key advantages of what they've done with the engineering to ensure that you can do the setup on site and that it can happen very, very fast. So while they're doing that, we just want to make sure that everybody understands in terms of the flexibility of the system. You've now seen in the presentation and the short animations and pictures that you can do a contact shot either with the large collimator, which offers 86 mils of shielding in tungsten. We're using the CP collimator, or you can use the normal conventional radiography collimator that you can see here, which offers a little bit more shielding but makes it very easier to wrap when you have tight spaces where the whole projector won't fit into. So when you need to go between tubes or into a pipe rack, you can use the shielded guide tube. The guide tube then just protects, it's got the same bismuth impregnated material to ensure low radiation levels when exposing that. And then with the guide tube connector that connects onto the projector. Just talk about the setups. You can also use this, obviously, the projector with a conventional guide tube if you want to, and then various different types of collimators, 60 degree, 90 degree, panoramic. It's a flexible system, and the Exertus range all have the same types of fitting and connectors, so you can interchange between your Exertus type of accessories and projectors, what you use. For close proximity radiography, we will always advise to utilize the accessories that you get in the system. Okay. So quickly, we'll chat about the actual stand and clamp. Now, of course, you can loosen this up because on a little 2-inch pipe, you're going to be doing 2 shots at least. Probably an A and a B shot at 45 degrees or at 90 degrees. Philip's going to loosen up that system, and even with the projector on it, you can swivel this to a full 90 degrees, tie it up, and it will hold its place with the projector and the mats there. So as long as you obviously use on a pipe that's not a thin walled pipe or and it's, you know the pipe's going to be strong enough to hold the total weight of the system, with the cone and the projector. And all the clamps, probably around 20 odd kilograms. Yeah, probably about 20 odd kilograms. Remember about the lead shielding cassette, but you can do an A and a B shot And obviously, once you've set it up the first time, swivel it around with everything connected. I think that's maybe something we should do for the guys to just see with the projector on. We'll see how much time we have. Ivan will quickly talk about just the setup and the connections that we've made very easy, and the engineering behind the dimples and the adjustment ranges on this for standoff shots and what you can adjust to.
So as Jan Albert has mentioned, a key feature is that our adjustment legs actually have dimples along its length. The advantage of that is when you assemble it and engage your wing bolt with one of these dimples, there's no possibility of the actual setup sagging or dropping during exposure, which obviously eliminates the possibility or risk of a reshoot because your system has dropped. Another accessory that you get is when you don't have space or choose not to use your cassette, and specifically on something like an elbow shot where these would be in the way, we supply straight legs as well, which you then just substitute. Instead of using these, you'll use these because you won't have the restriction of your legs when you do a elbow shot. Okay, so what we'll do now is we'll just reassemble everything and swivel it to its side so that we can see the effectiveness of the system. Okay, so now we will loosen the ratchet and swivel it towards Philip.
Again, I'm just holding the pipe to make sure. On a normal pipe rack, that wouldn't matter, but you'll see here the system obviously carries itself on that 45-degree angle. That is the preferred method for us to do an A and a B shot, is a 45 and a 45. Yes, we can go to 90. Does it put a lot of stress on the pipe? Yes, it does. If you need to do it, make sure your pipe can take it. If you need to do a single shot or a contact shot, just adjust for what you have available on site. Couple of key things about this cone. You'll see they wrapped it up there. That's to keep it in place. Actually, with the collimator in place, the cone will stay there. It won't go anywhere on its own. And you can swivel through that just by leaving the cone as is. Ivan, if you can tell the guys what the standard standoff is with the cone in place.
So currently this cone is designed to achieve a 350 SFD. It does have an extension which allows you to adjust it to up to a 450 SFD that is available upon request. The ellipse opening has been tested according to code on this specific angle, and it meets the requirements as well.
That's it. If your requirements requires a different SFD than the 350 or the 450 that's available, you can further adjust the ranges of that SFD up to here if you need to have that ellipse, but you would then use it without the code and just wrap that inside the mats. But we have found that the 350 and the 450 SFD, gives you that perfect ellipse. And then a lot of questions that we do get is about the little laser that actually goes on top of the collimator. So that's very easy to utilize this and line this up. Even if you are a bit at the top, because it fits so well over that collimator, you've got a direct angle to see if you are hitting the weld. It makes a little green line. And at that angle that they have these legs set at, if you have the projector higher up to do your alignment, you then drop it down, it stays in the same place. So you can always be sure that you are doing it correctly. So there's a little green light, if you guys couldn't see it earlier, just for that alignment. And that little laser attachment, I think, is creates a lot of stir with customers. It's something that guys wish they had for their conventional radiography as well. I think then, Abdul, if you want to take the chance to maybe ask a few of the questions that have been asked on the chat box, you are welcome to do so, and we can then answer them live right now.
Thank you, Jan, and thank you guys for this amazing demonstration. Some of the questions was already answered in the chat box, but we would like to read them again, so people can, everyone can hear the answer directly from you, which is a great thing. So going first to question number 1 from Andre. Andre have 2 questions. Is this system designed for SE75 only?
So yes, the GamCPR system is specifically designed for use with Selenium-75. I see there that he's asked, is it possible to use with Iridium-192? To achieve true close proximity radiography, you won't use Iridium-192. You will only use Selenium-75. Will some of the shielding materials used in the system have an effect with Iridium-192? Yes, it will. It won't have the same success and the same barriers, but if you are willing to go through the process and wrapping and see what your barriers are, you can utilize conventional radiography with the shielding materials on Iridium-192. To achieve the types of barriers we did here today, under 2.5 microsieverts at 1 meter away, you need to be using a Selenium-75 source.
Thank you. I think the reason Mr. Andre asked this question is because he's saying that SE75 is difficult to get in some countries. And
that could be true. I mean, I guess if he has a couple of examples, we can ensure. Gammatec ourselves, we export to about 70 or 72 countries around the world. If there is a country that has a problem with Selenium-75, get in touch. Let's see if we can solve your problem. What I can categorically state is that Selenium-75 is difficult to get hold of on short notice. It is an isotope that has a longer cycle, and you need to order in time. But Gammatec caters for that as well with our isotope management system. So although your first source might take a little bit longer, there's not a short turnaround as with Iridium-192. Once you are in that cycle, we ensure that you order in time to get a replacement source in time. Also, that the Circa 80 or the Exerter Selin 80 projector is one of our most popular models out there. So we normally always have stock of Selenium-75 on a month-to-month basis. So yeah, let us know those countries and we see if we can assist.
Thank you. I think you already also answered the second part of the questions, which is possible to use for IR192 Iridium, or do you have plan to make the same for IR192 in the near future? Just to confirm.
Mr. Ivan and Mr. Philip are always busy with new projects, and if you have any good ideas or any of your members have good ideas, send them across and we'll test them out, and they'll get onto that. Iridium-192 is a lot harsher and a lot more difficult to shield. If you throw money at the problem, I'm sure you can do it, but that's going to add a lot of weight. Yeah, it's going to add a lot of weight moving to different materials, and what we want to do is get that fine balance between, what the bulk of the work is, and the bulk of the pipe work is not that thick. Yes, you do get sites where it's extremely thick and you have to use an Iridium-192 source, but there's a lot of work, there's a bulk of the work on these sites that can be conducted with Selenium-75, and that's where the focus should be with systems like these.
Thank you, Jan. The second part of the questions, what will be safe distance for GamCPR? Is safe level, or is the safe level is 1 microsievert per hour?
Yeah, we can quickly show them the calculator. I think once we've run through the questions, while I'm standing here, we'll switch back and I'll show you the calculator where you can actually calculate that. But it's very easy. The calculator will help you calculate. It depends on what the distance is they want to achieve. We are already at 1 meter away. We're already under 2.5 microsieverts. If you go to 2 and 3 meters, which is in this little space, not very far away, you're going to be comfortable at background levels very, very quickly.
Thank you, Jan. Question number 2 from Mr. Ganesh Kumar. Please explain more about longer half-life.
Yeah, so the half-life of selenium-75 is 120 days. So every 120 days, your source will halve its strength. So if you buy an 80 curie selenium-75 source in 120 days, that selenium-75 source will be at 40 curies. Whereas with iridium-192, the half-life is 74 days. So if you buy an 80 curie there in 74 days, it'll go down to a 40 curie source, and then in another 74 down to 20 curie, and so on and so forth.
Thank you. Question number 3 from Mr. Vinod Kumar. Any profiles, clamps under development for CPR of boiler tubes in service inspection?
Ivan's going to answer that for us.
Yes, we have engaged with a customer in Qatar, specifically on in-service boiler tubes, and we are happy to share this individually with Mr. Babu. But yes, we have definitely worked on a solution for in-service boiler tubes. But we can also customize anything to suit your specific needs.
It will also be interesting to share this with the ASNT UAE section. If you have some sort of case study or something, some slides, we can post it on our LinkedIn page. It will be a great material to read for the members.
Thank you very much for the offer.
Thank you.
As soon as we've got something going there, we will definitely share it with you. I think, yeah, constant development and testing is part of our R&D department. So what we're currently doing is developing a panoramic shot for the GamCPR system. So instead of doing contact or standoff shots, we're currently doing development on a 36-inch pipe to be able to conduct close proximity radiography within a small area on a panoramic shot, and from 10 to 36 inches. Once that is released as well, we'll send that across to you guys as well. So yeah, any users like that or any cases, please send it across. We'll see if it is worth our while to take up and develop for a customer.
Thank you, Ian. Question number 4 from Mr. Andre also. What is the SE75 strength used for demonstration? I think he means this demonstration.
That's correct. Today we use a 24 curie selenium-75 source.
Thank you. Question number 5 from Mr. Ganesh Kumar. What is the weight of iridium-192 projector?
Okay, so yeah. So the Exertus, we do the same one in the Exertus. That one's about 22 kilograms, but the circa used in today's demonstration for selenium-75 is only 8 kilograms, very lightweight, as you see there. That's a small, nice projector. Obviously, bear in mind that the collimator itself offers almost the same shielding as the shielding in the projector, and that's also a couple of kilograms when you add the two together. But generally, very lightweight, very easy to maintain.
Thank you. I think I mistyped an answer in my questions, so I think Andre answered Ganesh saying there is no projector for iridium-192 yet.
Not for close proximity, no.
Yeah, thank you. Question number 6 from Mr. Prithivirajan. He's asking, what is the source strength you're using for this demo, which was already answered. I think you said 24 curie.
Correct.
Well, my memory is good.
Your memory is very good, yeah. Listen, yeah, we're in a very small space here. We're in a space that's about 4 meters by 4 meters. And obviously 24 curies is the source that we had available today that we use for our testing and stuff. But we easily go up to 60, 70, and 80 curies, even still confined to our little demonstration room in our building here. So guys don't specifically have to use a lower curie source. We will supply a full strength 70 to 80 curie source, and you use the GamCPR calculator and the wrapping to achieve the same type of results, very, very close to that you have already.
Thank you, Ian. Question number 7 from Mr. Brashobner. Can you show a setup for 90-degree shot on the side on the same pipe?
Sure. I'm setting it up over here. Our cameraman is going to come a little closer and maybe just hit it from the side here.
Well, that's great. That's an immediate answer. I will stop sharing my screen for now so they can see the camera clearly.
There we go.
Yep.
Our mobile camera. So that's full at 90 degrees. Jonathan, you want to come this side? More. So that 90 degrees holding onto the pipe, you'll see it's full of the lead sheets. The cone is in place. Nothing's moving. Projector is in place. You can do that 90-degree shot if you need to. No problem.
Thank you. I hope this answers Mr. Brashob's question. Should I go back to sharing my screen?
You can go ahead, yes. Sure.
Thank you.
Okay, any more questions on your side, Abdul?
Yes, we still have some more questions. Question number 9 from Mohammed Rizvi. Can you demonstrate pipe to flange? I'm interested also on this. It's very interesting that you can inspect the flanges. So that's very good.
Well, we can do pipe to flange. I don't think we've got enough space in our demonstration setup. The setup does have a little flange here. We can send him the animation and I can maybe send Mr. Mohammed some pictures, but the pipe to flange is not a problem. Just in our demonstration setup, we don't have it ready.
That's great. Actually, I can share Mr. Mohammed Rizvi email with you, and if possible, also to post it on our LinkedIn page. It will be great.
Absolutely.
That's a very.
What we could do
I think I was
make a short video for you guys of that setup, of that pipe to flange, and then share that across, and you can share it on your LinkedIn page. We'll go scratch around and see if we can modify either this setup or if we have a setup with a flange in play, and we'll do that for you and send you a short video, and you can then share that with your members and in your LinkedIn page.
Thank you. I was asked in the past about flange inspection, flange to pipe inspection, and I didn't know the technique. So now I know. If I get asked, I will contact you.
Thank you very much.
Okay. Question number 10 from Mr. VG George. Does the scatter radiation from the fixtures affect the radiographic film or imaging media?
So the very short answer is no. The long answer is that we've used the system with conventional film, with computed radiography plates or CR plates, as well with 1 or 2 modifications. We've utilized this with a digital panel, and none of it is affected by scattered radiation coming off of the shielding cassette, off of the cone. It's all very well absorbed. We've not had any issues thus far.
Thank you, Jan. We have more questions in the chat box, and since we have some time left, let's answer them. First, a question from Mr. Sebastian Fernandez. What is typical lead time required for developing a custom-built unit?
It depends on what he's busy with and what parts we have available to test with. But we would say about six weeks, dependent on regulation and things. But 6 to 8 weeks would be fine.
Thank you. Next question from Mr. Shajan. What is the maximum capacity of this projector?
So this cylinder circuit takes 80 curies maximum.
Thank you. I think this is the same question by Mr. Sebastian. I think we're done with the questions. I would like to thank you guys for this amazing presentation. It's a great technique that reduces the safety risks and also reduces downtime for plants. I remember when I was going to site, sometimes we were not allowed to go because there is radiography. Our work was delayed, or we have longer lunch time. We were happy, of course, but I know that the operation team is not happy. That's also the sensitivity of this technique, and the resolution is considered higher than, let's say, conventional RT, which is a great thing. So thanks a lot for sharing this information with us, and we are looking also to have you on the future. Thanks for Mr. Gareth from GNDT and Mr. Jan from Gammatec. Also Mr. Evan and the guys also who did the demo. Thank you very much. I would like also to ask Firas if he wants to add something, our UAE section president. Firas? I think Firas is muted. He cannot. Okay.
Sorry, is there a reaction needed from myself? I couldn't, it wasn't very clear. Ferris is the president. Okay, thank you.
No, that's I was trying to ask Firas to unmute if he wants to add something.
Abdurrahman.
Oh,
there we go.
Yes, Firas.
Sorry, I have not very good connection since I'm in Syria at the moment. But thank you guys for holding this meeting, and thank you Abdurrahman for taking care of the meeting as well. And looking forward for the next meeting from you guys.
Thank you, Firas. Jan, if you can share the presentation with me also, would like to share this with the members and whoever attended this webinar. We would like also to post this on our LinkedIn page, if possible.
Wonderful.
And please, people who want a certificate, make sure you provide the right email ID, because we are facing some problem with sending the certificates.
Yes, sure. And I just want to share the link. I'll stop share my screen and share the feedback form link. I think it's a little bit late, but of course, if you need the feedback link, just contact us and we can forward it to you. I will just share the link now. So please copy and paste in your browser and give us your feedback on this presentation. If you would like also to hear more about this subject, let us know. I'm right now sharing the feedback link. So please, everyone, give us your feedback. Your feedback is very important to us. Thank you, Jan and Ivan, for this presentation, and thank GNDT for arranging the presentation.
Abdul, thank you very much for the opportunity to present to you guys today. We really appreciate it. Very excited for your members to learn, kind of what is being developed at Gammatec. If anybody has any questions, please get in touch with GNDT. Gareth has a wealth of knowledge on the system as well, if you want that direct and personal contact. If you've got any other developments or any other questions, please check out our website. The website's got the full details of the GamCPR system. As you've asked, we'll ensure that we share the presentation, the PDF and the profile with you, so that you can share with your members. That's not a problem. And then, of course, presentations like this is kind of what we do and what we like to do. If there's any end user, if there's any customer that needs some convincing or that wants to look at the technology or have a further look at it, please get in touch with us. We'll arrange another demonstration for you guys, no problem. Just let us know. But yeah, once again, thank you so much for the opportunity. It was an honor, and I hope your members enjoyed it as well. Thank you very much.
Thank you.
Thank you, Jan. Thanks a lot.